To start everything off, we're going to talk about functions. So let's remember where all this comes from. A relation is any time you have a mapping or pairing of input values with output values. Of input with output values. So if I had 1, 2, 3, and 4, and they're paired up with some stuff over here. It could even be, I don't know, an alphabet. What I'm doing right now is called a mapping. We're mapping them together. But what it's actually doing is pairing these together. Now when it just says relation, it doesn't even matter how they're paired. I mean, to get to a function, we have to be a lot more specific. So let's talk about what makes it a function. A function is a relation. It is a pairing, but we're going to be a lot more specific. In a function, each input is paired with exactly one output. So up here, this would be considered a function. Now just to get a little bit more vocabulary, if you take the set of all of the input values, that is called the domain. And the set of all output values is called the range. So I wanted to make sure we understood that. So let's look at a couple more examples with this pairing. Okay, so here I've got -5 paired with 6, 0 paired with -1, 2 paired with -1, and 6 with 4. Is this a function? Is each input mapped with only one output? If so, then it is a function. So this is a function, yes. Well, let's see what makes it not a function. If this -7 was paired with the 2, and then it was also paired with the -5, this would make it not a function. No matter what else happens, this would be not a function. Because that input value is associated or paired with more than one over on this other side. Okay, so let's look at a couple of other things. Let me pause this for a second. Okay, so let's continue going through some examples and deciding whether it's functions or not. Here we have sets of ordered pairs. Each input can only be paired with one output. So 1 is paired with 2. 1 is not paired with anything else, so we're good. 3 is paired with 5, but 3 is also paired with 6, so this would be a no. Not a function because 3 is paired with 6 and 7. What about the next one? Okay, on the next one, 1 is paired with 1, 2 is paired with 4, 3, 9, -1, 1, -2. Each of those x values, or the first component in the ordered pair, do you notice it's not repeated? That gives you a clue. Now here, because the 3 was repeated, we'd look at what it's paired with, and it was paired with something different. Now, what if somebody had accidentally written down the same point twice? Well, it's the same point. That doesn't change anything. If it's paired with something that is not the same. Okay. X is a student of Y. Well, it depends on how you think of it. Now, here at the high school, each student does have more than one teacher, so that would not be a function. But what about elementary school? There are circumstances where one student may have only one teacher. Let's look at number 4. The relationship X is the biological daughter of mother Y. It is not biologically possible at this time for someone to have more than one biological mother. So this would definitely be a function. Now, when you're looking at equations, I want you to really get this idea about if you plugged in a value for X, how many values of Y would you get back out? To be a function, you have to only get one Y back out. So an easy one to plug in is 0. So if we plugged in 0 for X, we'd get 3Y equals 6, which means Y would equal 2. Another way to look at that is if you solve for Y, 2X plus 3Y equals 6. If I solve that for Y, I get 3Y equals negative 2X plus 6. Y equals negative 2/3, X plus 2. And there is only one option for Y. Definitely a function. Now let's look at the next one. X plus Y squared equals 9. You can either think through it like I did on the other problem, where you just test some X values, or let's see what happens when we actually do solve for Y. When I solve this for Y, I will get, let's see, we start with X plus Y squared equals 9. Solving for Y, I'm going to move the X over, so Y squared equals negative X plus 9. Uh-oh. I have to take the square root. That Y squared is going to mess me up. To undo something squared, we have to take the square root of both sides. Remember, when you take the square root of both sides of an equation, you have two possibilities. You either have a positive or a negative answer. Uh-oh. That means no matter what I plug in for X, there's two options for Y. So this one would be not a function. This next one, Y equals X squared plus 4. Well, it's already solved for Y. Does it matter if the X is squared? Well, no, that just is going to make it positive no matter what. It's not going to give me two options for Y. This is a function. So one easy way is if you've got the equations, let's think about this. If we have the equations, gosh, we can tell just by looking at the Y's. When Y is all by itself, it is. When Y is squared, or there's a possibility of having duplicate answers for Y, it is not. Now, let's see if we remember what to do if we have a graph. We have a graph here, and we want to know if we have a function or not. There is something called a vertical line test. Vertical line test says I'm going to send a vertical line down on my graph. If it hits more than once, then this is not a function. Oh, not a function. What about if I had a graph like this? What do you think? This would be a function. This would be a yes. All right, let's try another one. Now, what if it's in pieces? Like this. It almost looks like when I send my vertical line through here that it would hit 2 points. But if you'll notice, one of them is open and one of them is closed. This is the only point that we are actually really exists. This one that's open, we're not including that point. So this would be a function. The only time it would not is, again, when you have maybe something overlapping like this. That makes it not a function. Now, we also want to review function notation. So that's our next step, is to review the function notation. Function notation is there just really to give you more options for naming your functions. F of x. Let's say f of x equals 1/2 x minus 5. And then we wanted to have another function. We're going to name this other one g of x equals negative x squared plus 2x minus 1. Now I'm going to use the f to kind of give an example of what function notation really is, just to make sure we all are on the same page. This denotes the name of the function. The x is actually telling us what our independent variable is, or our input. This part is the rule. It's telling us what we're going to do with our input. So this rule says, for everything I plug in, I'm going to multiply it times 1/2 and then subtract 5. This rule says I'm going to take my input, square it, make that negative, add to that 2 times that input, and then subtract 1. So remember, this is just telling you what the input is. Now I want to remind you, this is f of x. This is called f of x. It is not, and I repeat not, f times x. Please do not make that mistake. F of x is another name for your y. It gives you the value of the output. Another way to think about it is f of x is the output of function named f when the input is x. So that's long, but I want you to get this idea that f of x is always giving you the output. So if we were asked to find f of 1, this is giving us a specific input. You would literally plug it into your rule. 1/2 of that input and then minus 1. That'd be 1/2 times 1 is 1/2. Minus 5 is going to give me negative 4.5. You actually came out with a number because it gave you a specific input value. Let's try f of negative 2. It's 1/2 of negative 2 minus 5. Going to give me negative 1 minus 5 will give me negative 6. Now we can also find values on g. G of 0. That literally means to take this function named g and figure out what the output is when the input is 0. So all we have to do is plug it in. Oh, it's nice when you're plugging in 0 because, gosh, you're just going to get that constant back. How wonderful. Now what if, let's just go crazy here, they had asked for g of n. So they're asking what would be the output when the input is n. So our input's not x anymore. It's not a generic x anymore. We're renaming it n. Well, gosh golly gee, you just plug it in just like we did. It's literally just going to replace your x. And that's the basics of how to work with function notation.